Hello everyone, welcome to QMoney Module 1. Let's talk about what you'll be doing in Module 1. This is the QMoney UI. You can select a username to pull up all of his or her transactions. You can also get the current returns of all stocks in the user's portfolio. Both absolute returns and the annualized returns are reported. Absolute returns are computed based on the returns on the stock from the purchase price till date. If a stock was purchased for 100 rupees 2 years ago and it is now listed at 200 rupees, the absolute return is plus 100 rupees or 100%. Annualized returns are the average annual returns on the stock over the holding period. In our example of the stock going from 100 rupees to 200 rupees in 2 years, we can use the compound interest formula to compute the annualized rate of returns as 41.45%. The absolute and annualized returns are used to make buy and sell decisions and compute the resulting gains or losses. This is the architecture diagram of QMoney. Notice the individual components. First, we have the front end. This is the QMoney UI you just saw. It is built using React. All the necessary front-end code has been provided to you and you won't be writing any React code in this micro experience. QMoney communicates with third-party stock services like Tingo and AlphaVantage to retrieve historical prices. This information is used to compute stock returns. Let's take a quick look at the two services. This is the API documentation for the Tingo service, which we'll use in the future modules. You can take a look at their website as well, the services they offer. This is the documentation for the other service, the AlphaVantage. We'll be using these APIs in the future modules as well. The UI you saw gets all of its data from a full-fledged QMoney backend application. This is running in your Cryo workspace. We have provided all the necessary code for the backend application and its interface with the front-end UI. The QMoney backend will use the code that you write in this micro experience to compute stock returns and send it to the front end. The backend code will not call your function directly. You will have to publish your code as a library that the backend will then import and use. Let's take a better look at one of the external API providers, Tingo. This shows an API call that has been made. We'll have to log in order to fetch this particular data. Here we've provided the stock symbol Apple and we're trying to fetch prices between this start date and this end date. This returns the data for all the days in that range. For each day we have these fields: the date, the close, high, low and open. This is also known as the OLHC data, and these are the fields we'll be using in the future modules. In this module, you will read a JSON file that has a list of historical transactions that a user has made and get the list of stock symbols for those transactions. You will be working on the Portfolio Manager library, which needs to implement this functionality. The process of converting Java objects to their JSON representation is called serialization, and the reverse process is called deserialization. We will use JSON, which is a popular Java library that can be used for serialization and deserialization of Java objects. You will deserialize the data in the JSON file using Jackson's object mapper and return the list of symbols for the trades in the same order in which they occur. In the bigger picture, this JSON data will be provided as input from the front end. However, for this module, we will use a local JSON file to test this functionality. Head over to the setup section and follow the instructions to fetch the Git repository. This repository will contain the files that you'll need to work with for this module. Once you've completed the setup steps, you will have all the necessary files in place. Let's take a look at the files you'll be working with for this module. This is what the repository would look like. You have the source main where the application code would be present. The source test is where the test related files will be present. We will take a look at the files relevant to this module. Let's take a look at a sample JSON file from which we need to deserialize and extract data. We have opened up the trades.json file that has been provided. This file contains all the transactions made by one user. Each transaction contains these four parameters: the symbol, quantity, trade type, and the purchase date. The symbol can be Apple, Microsoft, Cisco, Google, anything. Quantity is the number of shares in that transaction. Trade type is whether the shares were bought or sold. Purchase date tells us the date of this transaction. These dates would be in the past. If it's a new customer, the file could even be empty. Let's see where the entire application starts. That would be the portfolio manager application.java. The main read file function is where you'll need to write the code for this module. You will receive the JSON file as the first argument, args of 0, and you have to do these three things as shown in the to-dos. 1. You have to get the file object for the JSON file name passed. The file object will be used to read the data from the file. You will be using a method provided in this file to do that. We'll go through that later. 2. Get an instance of the object mapper that will be used to deserialize the JSON data to a Java object. You will be using another method provided in this file for that. Invoke this object mapper's read value method and pass the file object from the first step and the deserialized Java class structure to this method. The method will return an array of Java objects containing the transaction data from the JSON file. 3. Iterate over the list of Java objects and extract the stock symbols from each object. Store these symbols in an array list and return the array list. Let's go through these steps in a bit more detail. The resolve file from resources function has been provided to resolve the JSON file name to its absolute path and return the corresponding file object. Invoke this function from the main read file and pass the file name to get the file object back. Remember not to hardcode the file name, for example trades.json, because this would lead to test failures. Then create an object mapper using this method. You'll be using this object mapper during deserialization. Let's look at the Java object that will be created during this deserialization. That would be the portfolio trade.java. This Java class has a structure that maps directly to the fields that are present in the JSON file. The object mapper's read value method will convert the contents of the JSON file to an array of portfolio trade objects and return that. This is the deserialized form of the JSON data. Lastly here, iterate over the array of portfolio trade objects and use the method provided in the portfolio trade class to fetch the stock symbol. Store all the stock symbols in an array list and then return it. Let's see how to go about testing our implementation. The main read file method will get invoked from this test class. It passes the JSON file as input to the main read file method and compares the output returned to the expected output. To build the application and trigger the test, follow the instructions provided in the milestones. You will also have to resolve some check style or PMD errors for the build to be successful. These are tools that make sure your code style is consistent and follows a set of rules. For example, the indentation has to be consistent and the number of characters on each line shouldn't exceed 100, or unused import should be removed, etc. Make use of the references provided in the milestones to achieve this. Once the build is successful, you should submit your code for assessment by following the instructions in the last milestone. The skills you'll take away from this module are using Jackson's object mapper to deserialize JSON data to a Java object. With the code that you write in this module, you will be able to parse the JSON data sent from the front end and extract the stock symbols for all the transactions. We'll see how this will get used in the following modules. Good luck with this module.